So today we are going to see something, we call it Lex. Okay, it is basically lexical compiler, Lex compiler I should say, Lex compiler. Okay, what it does actually, it uses a language, something we call it a Lex language, and converts your Lex file into C file. Okay, it will be lex.yy.c. So this is your tool. Okay, maybe your Lex compiler. So what this compiler will do, it will take your Lex file, something .l file, and it will generate a .c file corresponding to the Lex file. What is it actually doing, right? So what it does is, it generates a lexical analyzer for you. Okay, what next lexical analyzer does, it has your automata kind of things which will keep track of all the possible inputs, right, all the possible characters, and then when some input comes, it can easily check it with the patterns. Okay, whether this pattern, it matches a particular pattern or not. In that case, the first thing that it can help lexical compiler is to generate the C program. If this Lex compiler would have not been, in that case you would have written this C program yourself. Now you are writing this Lex program, Lex file. Okay, in this Lex file what you are writing, I will tell you the structure. Writing the Lex file is very simple. You will just have a few declaration and then the rules. Rules means it will have, you will specify the patterns and what are the action to be taken when you get this pattern. Okay, this you have to specify only these few things, and this Lex compiler will automatically generate a .c file for you. And what you will do with this .c file, you will have a C compiler, in this C compiler you will send this lex.yy.c, and then you will get object file, right? It will be a.out normally, and you will give this a.out, you will execute this a.out, I should say, you will execute this a.out, and you will give some input and it will check whether it is what are the tokens actually, right? Okay, till now something that you want to ask, try to understand that till now what we have seen about the Lex, it is very basic. You should definitely have some questions on what is happening, what is this, that, what is, then I can tell you. So do you have to say something? If no, we are going to say a structure of Lex programs. First of all, let me tell you, you will use a programming language, you call it Lex language. Okay, means it is not that anything different, anything new, but you will write in a particular format. That is the only thing. Okay. So first of all, you will write. I am telling you the declaration. Sorry, the structure. So first of all, you will write the declaration part. After declaration, you will give this to % symbol. Then there will be transition rules. Basically, you will have the patterns kind of thing, that this pattern, whatever the patterns you want to have in your C program. Then again you will specify two % symbols, and then you will write the auxiliary functions. Means these are those functions which are being used here, auxiliary functions, or those functions that you want to be in the C file created. Okay. This is the very simple structure of your Lex program. You will have your declaration, some transition rules, and then auxiliary function. Okay, let me introduce one variable I want to say. It is YYLVAL. Okay, a variable YYLVAL. Okay, so this is a actually shared variable which will be actually in the end of your execution of your program. It will be returned. It will be returned to the parser. Whatever it has, it will be returned to the parser. Okay. What actually happens while analysis, or when it will execute with the parser, when a syntax analyzer works with the parser? If you remember, the parser will send an instruction of get token, right? So whatever the input stream is there, your lexical analyzer will start reading from this input stream, and from this beginning it will try to find the best pattern, the lexeme that matches the longest pattern specified in the lexical analyzer. Here you are specifying the patterns like what are the possible things. There are something called if is possible, else is possible, do is possible, and maybe other things are also possible. Along with you have specified some about certain symbols also. You have also specified about other things, what can be an ID, identifier you have specified. So you get a character and you try to match one of the pattern where it can be matched. If at all it is matched here, okay. So then the next character you try to match further. If it matches to any one of the pattern, then a particular token is generated. If it is an identifier, you need to store in the symbol table also, and then this particular token is returned back. This happens in this communication between parser and lexical analyzer. So here what you are trying to understand is this lexical analyzer, if at all you are writing yourself, you write a C program. This Lex program that we are studying today will help you in automatically generating this C program. You will just specify these patterns. Where you will specify these patterns? As a transition rules. Okay, and you will use this Lex compiler. This Lex compiler will create a .c file corresponding to these set of patterns that you specify. Okay. So this is the case about the lexical analyzer. Now let us have a small example. First of all, you will have declaration. So when you write declarations, you start with this particular thing. Okay, this thing, and you end with this thing. In between, you can define something. Okay, a declaration will start later on, from maybe here only. Here you will define something. Define means if you in your C program, usually what you do, you define some of the constants, literal constants, or any kind of macro also. Those are the things you define. So similarly, if you want to define some of the constants, you can do it here. For example, like you want to specify a character LT. For what? You want to just have a symbol kind of thing that you will return. Okay. Okay, you can have for less than. If you want to return something less than equal to, it can be equal to, it can be not equal to, it can be greater than or greater than equal to, or you may return what is the token, whatever if it is if symbol, else symbol. It can be an ID you can return it is a number. You can also return maybe if, then, do, while, whatever you have used, right? Now after assigning these things, what is the next thing that you will do? Definitions of your regular statements, regular expressions, right? You can have a digit, you can have letters. So digit is what? It is 0 to 9, right? It is just a space, no equal to. Okay. After that, you can have a letter. What is the letter? It can be A to Z or A to Z. If there is a comma in between. Am I audible?
Yes, sir.
Okay,
Yes,
sir.
sir. Yes, sir.
So can you understand these things that I am saying?
Yes, sir.
Okay. So actually we are trying to see, here we are defining the pattern, regular expression, and then later on we will use this regular expression in declaration part, in pattern, in rule part, है ना? So here we are declaring this is the particular regular expression for digit. For letter, if you want to have ID, what it will be? ID, if you want to define ID, it will be, you may remember, it will be first of all one letter, okay, and after that it may have any number of letter or digit, right? So you may have a letter or a digit, right? Any number of this. So you can specify this with a clean closure just by typing star after that. Okay. Now suppose for new line characters or tabs and those all things, you don't want to perform any action, right? So you just specify them and say that nothing to be done. Okay, you specify delimiter, delim, it is if it is /t or a space here, give a space /t or /n. Okay, actually here I have given a comma. We will have to check. Actually we cannot, we don't give this comma here, right? Okay, so it is just a space /t and /n. So this is delimiter. Later on we will see what to be done with the delimiter. Suppose let us think about any combination of these two, how many numbers of time it comes. Let me say it is ws, it is any number of delim, not clean closure, just plus, because one or more number of delimiters. If it comes, we will do something. Okay, we will specify that we will not have to do something. After that, number, what can be number? It will have digit only, any number of digits. Okay, you can have an expression also with the digits. Okay, if at all it is given digit plus, digit minus, digit all these things, this can also be possible. So suppose you have digit plus some more digits, or maybe some more things. Okay, whatever, maybe if you want to have plus minus kind of symbols, those all the things can be specified here, no problem. Suppose your declaration part is complete, then what you are going to do, you are going to start new thing, we call it your pattern. So first of all, let us define what to do when ws is encountered. Okay, when ws is encountered, you just specify nothing to do. Okay, do action. Now you can have suppose after ws after ws we have written suppose all those things like if else, and those things. Suppose if he's coming, so what you want to return? Return the constant if. Then parser will get this constant if, relate this token kind of thing. Accordingly, it will decide what it has to do. Return. For suppose else, what you are going to do? The return whatever you have written there. You want to specify else. Then, if at all you have recognized an ID with the given pattern, a specified pattern, then what you can do? This ID, you cannot just return the token for ID. Yes, it is ID, no problem. You will have to also insert it into the symbol table, right? So you let us have val l val is equal to some integer, and after that you will perform some operation to install the lexeme. Okay, whatever this lexeme, that this is val, you have kept an integer. This will point to the first character of that particular lexeme. So you will, let me write a function. Suppose it is install the ID. Okay, so you will install the ID. That means you will put this information about the ID in a symbol table. Whatever the lexeme that you have found, doesn't matter how much character, definitely there will be some rule, but of different languages, but still in C you are getting an ID from the start symbol, from the start of this lexeme specified by integer. You will get this particular lexeme. You will consider it as an ID, store this ID in the symbol table, and then you will get the address, I should say the location of that particular lexeme in the symbol table. That will be your ID. Okay, so that particular pointer is in ID, and this pointer will be returned. You will return ID. Okay, this was the case of ID. Similar will be the case of number. If it is a number, definitely there will be somewhere it will be pointing to the start of it. Let us take val is equal to integer, and then you will have to install it. Let me call it a different function. It is a install number. Sometimes you may not need a different this kind of thing, as we have seen earlier also, but you can have this number pattern also, no problem. Install num. So what it does, as you are installing the ID, it will install the numerical constants. Definitely in a symbol, not in a symbol table, in a different table. It will have a different table. Symbol table will be different. It will have only the information of ID. Here you will put the corresponding number, and you will have the address of this place. Okay, and this will be returned. Okay, so for returning also you will write here what you want to return, the number. Okay, so here you are saying that it is a number. Okay, I should have written it in capitals, right? It is a constant specified above, right? So you have a specific return that it is a number with the value, means whatever the address, and once after that you are getting the this ID and number you have specified. Suppose you have to specify for this symbol, specify for greater than symbol, okay, greater than, less than symbol, or you have to specify equal to symbol. Okay, so you can specify. What you can do here, you can just keep LT, GT, right? For greater than, you take y by lval is equal to what? GT, right? And then you will have to return. So this y by lval is there, so parser will automatically know that it was a GT. Similarly, it will be LT and other symbols as we have specified, right? And after all these things have been declared, you will close this part. This was declaration, sorry, whatever it was, means patterns, rules, and then now you are specifying the methods. Here I can see two methods have been used, which was install ID and install num. So whatever methods that are being used here, you will have to define here. It will be your, what does it return? It returns the address, so integer, install ID. Okay, you will give the definition, whatever you want to do here. After that it will be install number. Okay, so it will also have whatever things you want to write here. That is it, and it is complete. This is your complete program. You have to just define certain variables, sorry, these constants if you want, if you need in your program, and then you will declare the regular expressions like digit is something, letter is something, what is ID, what is delium, what is number. Once specified these information, you can specify the rules, what to do. So if comes, you will have to return if, else, then else, if ID, then ID, and you will also have to keep it in the symbol table. So that is the thing. After number, for these symbols you have specified what you want to return, and accordingly you will return it. Okay, so this is the story of your Lex program. Once you have written this Lex program, what you are going to do, after writing this Lex program, you will actually compile with your Lex compiler. Whatever you have written, you will save it with your program dot L. This .l file will be given to your Lex compiler. This Lex compiler will generate one file. It will always be the same name, lex.yy.c. Okay, C. Now this lex.yy.c will be given to your C compiler. It will generate a.out, and that you will execute that a.out with the input stream. Whether you give it manually, you will give a file, or manually, whatever, and then you will get a sequence of token. Usually this lexical analyzer is used with the parsers. So parsers usually ask these to um, give the next token. So it generates a token with the whatever the possible token is, and give it to the parser. So that is what is happening in your Lex program. What you can do is you can also install this Lex program, Lex compiler on your computer. You may get this Lex as a we call it Flex nowadays. Okay, Flex. Okay, so you will be able to install it, and you will write your program in .l file. You will write it in a notepad. You will save it as .l file, and then you will compile with the Lex compiler and generate the lex.yy.c. Then you will use this lex.yy.c and compile with .c program. This is the thing that you are going to do. For compiling this .lex file, what you will write? You will write lex dot file name program. Sorry, why dot? Just a space is enough. Lex space the file name program dot l. It will generate your lex.yy.c, and then you can compile this. I think whether it is GCC or CC lex.yy.c, it will generate your a.out. Then you can execute your a.out. Now for reading this Lex, you can definitely in your Ullman also a basic introduction is there. However, you can go for a separate book. Let me name it. It is written. It is just you will search for Lex and Yak. Okay, it was written by John R. Levine and Tony Machon, and one more is there. Okay, so first, just with this name you can easily get Lex and Yak. You can get this thing, and it is not that only it will be used with the parser. Sometimes you will also say that if you want to print something or these kind of things, you can definitely write this Lex program, compile it to a C program, compile the C program, find the dot this thing a.out, execute it, and you will be able to print or whatever functions you want to implement, that can be done. So this is the story. Now I believe I will tell you some more things in next class. For now, if you want to ask something, please go ahead.